is that a lot of web applications have default icons. So you can connect to a website, and then this script will come back. It'll download the icon, it'll hash it, and then it'll say this site is probably running Joomla, or this site is probably running MediaWiki, or something like that, which is interesting information for someone testing a website. So this script was submitted. It was a guy named Vlatko Kosturiak, and I've heard that he may be in the audience. Are you here?
Oh, there he is.
There he is. All right. If you didn't know, today is Buy an Nmap Developer a Drink Day, so you're right on time. So we got the script, and it was a great script, and it did everything right. Just one problem was that the database was kind of small. It only had about a dozen entries, and we weren't sure how good they were, how current they were. We wanted to really back it up and have a quality database to ship out to Nmap users. Whenever we build a database in Nmap, we really like to back it up with real results. And also, we just like to do a lot of scanning. So that's kind of an excuse for us to build our databases. All right, so what are we going to do? How are we going to collect all these icons? Does anybody know of a tool that you can use to scan millions of internet sites? A tool that is scriptable, perhaps? OK, so it's an obvious choice for us. We're going to do this with Nmap, and it's a good choice for an NSE script. So I wrote this script called favicon survey. If you download Nmap, you're not going to find this script because it was sort of a throwaway script just for this survey. But I wrote this, and it does just what I said. It connected to a bunch of websites, download the icons, hashed them, build a huge database. Let's compare writing this as an NSE script to writing it as, say, a custom Perl or Python script, which would also be a viable option. If you're writing a Python script or something, it's easy to write code to connect to a website, download the icon, do the hashing and everything, and run it against one site. But then you think, to make this really fast, I've got to parallelize it. And then you've got considerations like, what if the site requires SSL and things like that? All of that is built into NSE. You get the SSL for free, you get the parallelization for free, so it's really a good fit. We had to decide which hosts we're going to scan. There are some advantages to doing just random IP addresses because you'll get people's home cable modems and things like that, which are useful for fingerprinting. One problem with scanning IP addresses with HTTP is that you don't always have a host name, and sometimes that's required to access certain resources. So we decided against that, and we did a big survey of just the external links of some large web databases. So from the Open Directory project, we got about 5 million links. We took the 4 biggest Wikipedias and took all their external links. Obviously, there's going to be some overlap. We put it all together, and we had 8 million unique domains. An Nmap developer named Brandon Enright did all this scanning. As I recall, it took a few days. And in the end, we ended up with almost 1 million icons. About 80% of those were image files. About 20% of those were non-image files and error pages and things like that, which also can sometimes be useful for fingerprinting. Now this is great. So we did all our results. We looked at the top 50 or so icons. We went and verified them manually. And we built a database. And that's what you get if you download Nmap now. You'll get a database of these top icons from this huge survey. But to me, it's sort of disappointing to do days of scanning and get gigs and gigs of data and end up with a 50-line data file. So we tried to think of something more creative to do with this. We ended up doing a second scan of the top 1 million web domains as published by Alexa. They publish their top 1 million domains, and then they also publish a number that they call reach, which is just sort of a measure of how many people visit this site in a day or a week or whatever it is. And so we had the idea, we'll just get these icons, we'll pack them together into a graphic, into a visualization, make the size proportional to the reach, and just see what it looks like. So here we've got a small example, but I've got something even better. If you go to nmap.org/favicon, if you're interested in exploring this data set and learning more about this scan, because there's a lot of interesting technical information, you can go to this website, and we built this really nifty zoomer and scroller so you can kind of explore this picture. So let's take this and kind of zoom in on a portion of it. All right, so you can see you kind of scroll around and things like that. But what do we see here? This should be familiar to everyone in the audience. All right, let me apologize. Some of these icons are a little PG-13, but we've got nmap.org here, some cute little Mario mushroom. We've got little Tux penguins. So it's kind of fun just to browse around this and see everything that you can see. So I encourage you to kind of check it out. And if you want to see a certain icon, if you suspect that your site may be in this top 1 million, there's a little lookup function. And it'll find it and zoom in on it, as if that was a hard icon to find, because obviously Wikipedia is one of the biggest sites on the net. All right, no examples right now. We don't have time for that. But what I'd like to do is, so we like this graphic so much that we decided to turn it into a physical poster, which is what we have here. So here you've got the whole thing. You can see the big graphic. I mean, a lot of things stand out here. Google is easy to see, and things like Facebook and Yahoo and YouTube. But here's this, and we've got the top 70 sites identified and classified here, and just some further information about the scan. This is a really swank poster. It looks great in a living room. There are only 15 of these posters in existence. This one happens to be signed and numbered, and we're going to give it away right now to whoever can win the icon identification contest. So real quick, someone near the front, hopefully, who wants to participate? Raise your hand. All right. I'm going to pull up an icon here, and you got to tell me what website or project it belongs to.
And don't yell it out.
Yeah, the comma is supposed to be there. Okay, this icon right here. Do you know what that one is? You got it, all right. So here. Thanks very much. I'll bring this down here. I'll bring this down to you, and Fyodor's going to continue on, talk about writing NSE scripts.
Oh, the answer was OpenBSD.
There you go.
All right. Well, that was certainly a neat and creative way to use the Nmap scripting engine. Can you guys still hear me? How about now? All right, good deal, thanks. So that was a nifty and creative way to use the Nmap scripting engine. But basically, in all three of these examples so far, what we've been talking about is how to use NSE and the scripts which come with it, which is certainly very valuable in and of itself. And most casual Nmap users will never go beyond using the scripts that come with Nmap. But let's be honest here. Any script kiddie could do that. What happens if you're the network task you want to perform, we don't already have a script to do that? Or what if we have a script and it doesn't do exactly what you want it to? Well, this section is going to show you how to solve that problem and some of the benefits you can get by writing your own NSE scripts. And the good news is that even if you don't consider yourself a particularly great programmer, we've tried to make it as simple as we could to build these scripts so you can do it quickly, even for tasks that you may only want to do once or twice. So what we started with is a nifty little language called Lua. And I have the main book, Programming in Lua, here, which is a great book. And it's a simple enough language that only the first 80 pages document all of the syntax and grammar of this language. And so I want to show you a very brief introduction to Lua and the reasons why we chose it. Like I said, it's very easy to learn. If you know other scripting languages like Perl or Python, or even languages like C++, a lot of the syntax for looping and variable declaration and the like is very similar. It's tiny to embed. The book says that the complete distribution, source code, manual, plus binary for some platforms, all fits comfortably on a floppy disk. For those of the young people in the audience, a floppy disk is sort of... Yes, it's kind of between punch cards and flash drives in the technology range. So being small is very important to us because we don't want to bloat Nmap downloads with some gigantic language. Also, it was important to us that it be widely known, used, and debugged. It was created in 1993 and still actively developed, so we knew it had a good track record that we're not going to start with some brand new language that then they're going to stop developing or, give up on. It's best known for its use in the game industry with games like World of Warcraft and Crysis, but it's been taking a real strong foothold in the security community lately. Nmap can use it for NSE, Wireshark can use it for its protocol dissectors, and Snort 3.0 has a Lua interpreter. So by learning this one language, you can actually apply it to a range of popular security tools. One holdout from the Lua bandwagon is Metasploit, which is still in Ruby, but every time I see HD Moore at conferences like this, I talk his ear off on why he should change to Lua. I think that's why he's been avoiding me lately. A few other reasons: it's extensible. So instead of using Lua's default socket and networking code, we hooked it to Nmap's fast parallel networking libraries. It's safe and secure. Take the example of Wireshark with their protocol dissectors written in C. Yes, it solved the thing of allowing a lot of different users to contribute dissectors for an enormous number of protocols, but a huge number of them turned out to be insecure with bugs like buffer overflows and format string vulnerabilities and things that are specific to languages like C, where you do your own memory management. It's portable. Nmap, you may know, we distribute binaries for Windows, for Mac, for Linux, and it works on the BSDs, on Solaris. And we needed a language that works on all of these machines too. There's even an Amiga port of Nmap for people who are into that. And Lua works on all of the platforms we wanted to support. It's also an interpreted language. So if you make a mistake in your code, you can just change it and rerun Nmap, and you don't have to worry about a bunch of makefile steps and compiling things. So that's Lua itself. Now we'll look at what NSE adds to Lua in order to make it more effective for network scanning. We have protocol and helper libraries. The idea is that we want Lua to be easy to use, and so you can do things like make MSRPC queries and HTTP GET requests without getting bogged down in all the details of handling the specific protocol. So we have libraries for DNS, HTTP, MSRPC. We have a packet library for constructing raw packets, SNMP. David's going to talk about the username and password database a little later. Basically a bunch of scripts that are optimized for writing network discovery tools. We have protocol brute forcers. One problem you sometimes have is you write a nice script that exercises a certain protocol on your target machine, but it requires a username and password. Well, with our brute forcers, you can more efficiently discover that username and password so that your script can continue. We have SSL, as David already mentioned, and we have a dependency system so that if we scan Microsoft and do SMB enum users, if we had done SMB brute as well, it would have taken that user, it would make sure that the username script runs first, and it would take those usernames and use them to brute force the passwords. So that's basically the nuts and bolts of what NSE is in terms of its infrastructure. I think now is a good time to get a little bit more concrete in things and actually look at the source code for an NSE script. The one we're going to